JMath.
Let's practice a few questions on trig triangles where you use the sine rule, the cos rule, or the area rule to solve whatever they ask you. Please pause the video, try the questions, and then after you're done, let's mark them together and see how you did. Let's look at the first question. So please don't mind the numbering. I just copy and pasted this from all the exam papers. So it's not question one, but it's the first question we're going to do. In the diagram, points B, C, and D lie on the same horizontal plane. That just means it's flat on the ground. That's why it's gray. Then they tell me there's two angles equal to alpha, there's a theta, and there's a side that's equal to K. They also tell me there's two equal sides in that triangle. So just always take note of everything they write in the paragraph, because sometimes they don't show it on the sketch and then you're lost if you didn't read the paragraph. First question. Prove that AD is equal to AC. So if I just highlight for my brain to just realize what they're looking for, AD equals to AC. So it's all part of triangle ADC, the one in front, but I don't have any info except that there's a side K in that one. So what I'm actually going to do is use congruency. So this takes you back to grade 9 to actually prove this is equal, because if the triangles are congruent, then all the sides and all the angles will be the same. In grade 9, everybody taught you that you start a question on congruency with in triangle ABD, okay, so the green one, and triangle ABC, the purple one. Then I need three aspects that are exactly the same, and then I can say therefore they are congruent. So firstly, I can see there's a 90 degree in both of them. So I can say angle ABD is equal to angle ABC is equal to 90. That was given. Okay, I see that DB is equal to BC. That was also given. And then lastly, AB is a common side. So I can just say AB, common side. And therefore, triangle ABD will be congruent. Remember, three horizontal lines to triangle ABC. And the reason I used, so remember the four reasons, I have side, 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 angle, angle side, or 90 degrees hypotenuse side. In this case, we used the 90 degrees, but we didn't use the hypotenuse. So that one is out. We didn't use two angles. That one's out. We didn't use three sides. So the reason is side, angle, side. Yeah, I know that's a big flashback to grade 9, but you still need to be able to do it in grade 12. Now, because they are congruent, I can then just say, therefore, so AD must be equal to AC. The reason you can write down there is congruent parts of congruent angles, or you can just write congruent triangles if you're a bit lazy like me. Question 2, prove that BD is equal to K over 2 cos theta. Okay, so first let's find BD. Okay, it's that green side over there, is equal to K and a theta. So remember, I'm always going to check the variables they put in there to figure out which triangle am I using, because BD is part of two separate triangles. But in this case, I'm going to use the gray triangle. Now, in that triangle, I can see that if I make BD green, then angle C would also be green. And then I can see that I have to use a K, and K goes with angle B up there. I need to find values for that. And luckily, because of all the info they gave me, this is an isosceles triangle. So this angle would also be theta. Sorry, it's a bit difficult to see. That's also theta. And then the purple one would be 180 minus 2 theta. Now I can use the sine rule. So I would start with what I want. I want BD, and that is over sine theta, would be equal to DC, which I know is K, over sine 180 minus 2 theta. Yeah, I want BD alone, so I'm just going to multiply over, so that's K sine theta. Now, something you need to remember, reduction rules, grade 11, sine 180 minus is the second quadrant. Sine is positive there, so that is just sine 2 theta. In grade 12, we learned that sine 2 theta can be written as 2 sine theta cos theta, and therefore the sine thetas cancel out, and that's how I get their answer, K over 2 cos theta. Question 3, determine the area of triangle BCD, so the gray triangle, in terms of K and a single trig ratio. So remember, area is equal to half, and then the formula sheet says BC sine A, but in this case, I want to use angle D. So then it is going to be BD times DC, and then sine of angle D, which is just theta in this case, but let's make it a D, so just see where I'm coming from. Okay, now I can replace all of that with, we just found out BD is K over 2 cos theta, and DC, they just told me, is K. I'm just going to put it over 1, and then this is just sine theta. So to simplify that a bit, this would be K squared sine theta over 4 cos theta. They asked me for a single trig ratio. Sine over cos is tan, so this is K squared tan theta over 4. That was the 2D, 3D trig question in that year's paper. Sorry, I don't know which year this was, but it could have been tricky, but if you just follow the rules, you would get to the answer. The second question we're looking at is question 10. It comes from an IEB paper from, I think, 2020s, somewhere there. But let's look at it. I don't think it was too difficult. Calculate the length of CD. So remember, firstly, just read everything that they tell you. But they were very nice to me, and they filled in everything on the sketch. Now, if I try and find CD, it's part of this little triangle up there, but also part of the big triangle. But I now need to figure out, do I have enough info to just use it? Now, I don't know what this is. Otherwise, I could have used cos, 2 sides and an included angle. But I don't have enough info, so that's not going to work. I can't use the sine rule because I don't have this angle or that angle, so that's not going to help me with sine rule. But if I focus in the triangle that CD is in, this one, there might be enough info. I just need to do a few things initially. Okay, first thing I'm going to do is I'm going to find the other angle at angle E. So I'm going to say CED, that angle, is equal to 180 minus 45, which is equal to 135. Now, I know it's not Euclidean, but because you used a Euclidean theorem, angles on a straight line, just write that for them. You never know when it counts a mark and when it doesn't. So angles on straight line. Now I know that is 135 degrees. Okay, if I look at that small triangle, that actually now goes with side CD. In that triangle CED, I can actually use the cos rule to figure out CD, but firstly, I just need to find the length of side CE. And from that, I'm going to work in this triangle to find that. I can then use the sine rule there because I have all the other info that is needed. I know there's an 80 and there's a 45. So if I set up my sine rule, I will get CE over sine 60, the green parts, is equal to the purple parts, because I started with the side on top. On the other side, I have to have side on top and the angle at the bottom. Now I can just multiply over and type it in the calculator to find the right answer. Luckily, they didn't tell me this is without a calculator, so the answer is 97.9795. Just keep it on the calculator because I'm not allowed to round off. Okay, now I can move over to the triangle that has CD in it, that long, thin one. And there I can use the cos rule. So I'm going to say CD squared is equal to ED squared plus CE squared minus 2ED times CE, and then cos of angle E. Now I can just fill in everything and see what the answer is. And the final answer is 140.54 meters for CD. With question B, if the angle of elevation of B from A, okay, so that's that angle there, is 37 degrees, determine the angle of elevation of the midpoint of BC from D. So I drew in a green line, and they want to know that angle there. What is that size? Okay, so there's a few steps you need to follow. You can't just, we don't know anything in the green triangle. So we need to figure out, firstly, what is the length of BC? Now, I can just use sine rule there, or the rectangle rules with opposite, adjacent, and hypotenuse. It's going to be way easier, but I'm just going to show you guys the sine rule in this specific triangle. But to use that, I need to find angle B, and I can just say 180 minus 90 minus 37 gives me 53 degrees. And then I can say BC over sine 37 will be equal to 80 over sine 53. And therefore BC, if I multiply over the sine 37, will just be 60.2843, and then just keep it on your calculator. Now that I know the length of BC, I can use it in the other green triangle. So let me just redraw that so it just looks a bit easier to work with. And if I redraw that, I can see I have an opposite of 60.28, but they said it must be half of it. And I have an adjacent side of 140.54 meters, so the answer for CD. In this case, I will not go sine rule. I will really go opposite over adjacent because I don't know any angles in that triangle. It is possible, it's just way more difficult than it should be. So I'm immediately going to say opposite and adjacent is tan, so tan of theta is equal to opposite. So I know that is just going to be 13.14 over 140.54, so the answer for CD. Great, and therefore theta, if I shift tan, that value will be 12.11 degrees. Great, guys, that was an IEB question, so it needed a bit of further thinking, but I really don't think it was too difficult. In the diagram, DBC lie on a horizontal plane. So again, that's the triangle on the ground. AB is a vertical tower. The angle of depression from A to C is 30 degrees. Now remember, if you see that, immediately use alternating angles to just put the 30 degrees down there. So that dotted line is always parallel to the ground, and that's why I can just transfer the 30 degrees. Okay. Then they're telling me other info, but everything's on the sketch. Determine the length of BC in terms of h. Now, again, I can just use the sine rule, but I need to fill in the other angles. Now, this is all 180 degrees. So in the white triangle, I can just say angle A is 180 minus 90 minus 30, so that's 60 degrees. In grade 12, you can write it down, but you're not going to get a special mark. This question is only 2 marks, so just write down the 60. With sine rule, they want BC. So for question 1, I can say BC over sine 60 will be equal to h over sine 30. And therefore, if I multiply this over h sine 60 over sine 30, it would just be equal to root 3 of h. Question 2, write down the size of angle DBC in terms of beta. So it's a triangle, the great triangle they're talking about. So I can just say angle B is equal to 180 minus, remember your brackets, 90 minus beta, and then minus, it's an isosceles triangle, so 90 minus beta. Okay, the 180 minus 90 cancels out, and then I'm multiplying the minus in with the b's, so that's just going to be 2 beta for that answer. For question 7.3, show that DC is root 12h sine beta. Yeah, I'm looking at the great triangle because that's where DC is located. I filled in everything that I know, so because it's an isosceles, I have 2 sides that equal to root 3h. And if I look at that, I have 2 sides and an included angle. So I can actually use sine rule or cos rule in this case because I have enough info. I'm just going to go for cos rule because I think it's a bit easier for this specific one. So I can say DC squared is equal to DB squared plus BC squared minus 2DB BC and then cos of angle B. So let's just fill in all those values and then simplify it as far as possible. So now if I look at where I want to end and where I am now, the cos 2 beta is not part of where I want to go. But luckily there's an identity for that. So I can just replace that with one of the 3 identities, but I want the one that is specifically going to give me sine. So I'm just going to change this to 1 minus 2 sine squared beta, because now I can just multiply that in. So I have 6h squared minus 6h squared plus 12h squared sine squared b. So the 6h's cancel out. And then, because this was DC squared, I can now just say this is the square root of 12h squared sine squared b. And everything that is squared in the root can go outside. And then I am left with their answer. So root 12h sine b. So how did it go with these ones? This is what you can expect in exams with sine rule and cos rule sums. You'll only get one of them, and it counts between 7 and 10 marks in each paper. How did it go with yours? If you still don't feel confident with this concept, please go back and watch the videos again and just sharpen your skills for exams.
If this video helped you, please like and subscribe.
JMath.